In a previous video, I had looked at this example, x of s is equal to 3s plus 8 divided by s plus 1, s plus 4. And I said, okay, we can solve this by using partial fraction expansion. So I had an a over an s plus 1 plus a b over an s plus 4. And what I did was I solved for my coefficients a and b and then took the inverse transform of this. Now, in this video, I'm not going to be using the partial fraction expansion. Instead, I'm going to be directly using my Laplace transform tables. Now, this is going to really depend on how many entries you have in your Laplace transform tables. In my case, I'm using the tables from Palm System Dynamics book, and it has about 35 entries in it. So these are the two entries that really, when I was looking at this, stuck out in my mind as maybe I could potentially use them. And this is what you need to go through. So I looked at this example right here, and I saw that at the denominator, I had an s plus something term and an s plus something term. When I looked at my tables, these were the two that I saw had a similar format. So I saw an s plus a and an s plus b. So that looks almost exactly like this, where a is equal to 1 and b is equal to 4. Now, the only difference is which one of these will I pick? Well, when I'm looking at this, the example I'm using has an s term in the numerator, and it really, this top entry has the s term in the numerator too. This just has a 1. So I really want to try to fit it into this table entry over here. Now, you have to be careful. You can't just say, all right, this is going to be 3 times s. It doesn't work like that. We have to modify our equation we're working with to fit the table entry. So really, what we need to do, we don't need to do anything in this example with the denominator. The denominator is already in this form. We just need to work with the numerator. So the numerator, I need to get rid of that value in front of my s. So I have 3s plus 8 over s plus 1 times s plus 4. And I'm just going to factor out a 3. But when I factor out a 3, I do need to be careful, and I just need to remember that I can't just say this is going to be 3 times s plus 8. I have to remember that if I'm factoring out a 3 from the s, I also need to factor out a 3 from the other terms in my numerator. Okay, so now this is times s plus 1, s plus 4. I can rewrite this a little bit differently, right? I can take this out of it to make it look more like this table entry. I can say, okay, I can just rewrite this as a times a 3 over 1. And now my p term from the table entry is really just 8 over 3. And it was before, but now this looks exactly like this table entry. So because it looks like this table entry, I can go to its solution and I can just start writing its solution. I do need to remember that I am multiplying whatever I do by 3. So I start by 1 times b minus a. b minus a is going to be 4 minus 1. So 1 over 4 minus 1 times, okay, p minus a. Let's do this off to the side. So if I have a p minus a, this is going to be 8/3 minus a, which is 1. 1 can be rewritten as 3 over 3. So this is going to be 5/3. Okay, so this is going to be 5/3 e to the minus a, so 1t, okay? And then minus, and now we have a p minus b. So p minus b is again going to be 8/3 minus 4. Now, so to get it to a 3, what can I can multiply it by a 3, so 12 over 3, so that's equal to 4. And this is going to be equal to minus 4/3. Okay, well, this minus is going to combine with that minus, so then I'm going to have 4/3 e to the minus b, so minus 4t. And now I just need to simplify. So this term right here, well, I don't know why I wrote it as 4 minus 1. We just have this is equal to a 3. And this term and this term are going to cancel out. So I get a 1 over a 1. So my solution, my inverse Laplace transform of my function x of s is going to be equal to 5/3 e to the minus t plus 4/3 e to the minus 4t. And this is the same answer that we got when we were using partial fraction expansion. Now, this way may be easier to you. Maybe partial fraction expansion is easier to you, but now you have options on how you can work different problems.